Hi dear students, let's see this question that came in JEE Advanced Paper 2 Physics in the year 2018. The question is fairly simple. Many of the students got it right, but yes, many of the good students also got this wrong because of in the process of saving some time, they got this question wrong. They tried to use the logic of SHM in this question and they made a careless error and hence they got this wrong. So we are talking about some good students over here. So we will see two approaches to solve this question. One, a fairly simple regular approach, and one using the same concept of SHM, but we'll have to be slightly careful over there. So let's see first by using the simple concept or regular method. So what's happening over here, there's a particle of mass 10 to the power minus 3 kg and charge 1 coulomb. It is initially at rest. At time t equals to 0, it comes under electric field whose variation with time is E naught sine omega t. That means this electric field varies sinusoidally in the positive I cap direction. E naught value has been given, omega has also been given. We have to consider only electrical forces and we have to find the maximum speed attained by this particle. Now we have to realize that let's say the particle is at origin. So at time 0, force starts acting in positive x direction and hence we can say the particle will start gaining speed in positive x direction. So it's very easy to see till the time force acts in positive x direction, till that time particle is going to gain the speed. That means it's going to accelerate. The moment force becomes negative, particle is going to retard. That means its speed will start decreasing. And hence we'll have to see that till what time the force remained positive. Now if you see this function, so it's very easy to see that the angle of sine omega t, it will start from 0 at time 0, and the moment omega t becomes pi, it will again become 0. If you see the graph of sinus sine function, so it's like that. So the moment, so this is 0, this is pi by 2 and this is again pi. So basically in this region the sine theta will remain positive. After that sine theta will become negative, and hence we can say when omega t becomes pi, at that moment, till that moment rather, the force was positive. After that force would have become negative for some time and again it will become positive. Sinusoidally it is repeating. So we have to find the maximum speed, and we have realized that the maximum speed will occur when the value of omega t becomes pi. Now this question is easy. So we can say that m into dv by dt, so this is the force, will be is equals to q e naught. Now dv is equals to q not e naught, this is qe. So dv will be is equals to qe. Let's put the value of qe naught sine omega t. This is qe by m dt, and hence we can integrate. At time 0 the velocity was 0, and at time, let's say, omega t, so this will become time t will become omega t becomes pi, therefore we can say that t would have become pi by omega, right, or half the time period from 0. So this becomes v, this is q e naught upon m. The integration of sine theta is minus cos theta upon omega, and from 0 to say pi by omega. Let's substitute the values. So q is 1, e naught is 1, m is 10 to the power minus 3, and omega is 10 to the power 3. So together they will again become 1. Minus sign is here. Cos of pi, which is minus 1, minus cos of 0 is 1. Hence this becomes 2 meter per second. Therefore velocity will become 2 meter per second. This is the regular approach. So those students who adopted this method got this question right fairly simply. Now, some of the students thought of doing this question by SHM, and they thought that the maximum. So let us first discuss what those students did. So basically, they thought that maximum force is m. Maximum force can be written as omega m omega square a, because maximum acceleration in SHM is omega square a. So m omega square a is the maximum force, we can say. So this will be is equals to q e naught, because maximum, so maximum value of electric field is e naught. So from here we can find the value of a. From here we can find the value of a because m is given, omega is given, everything is given. Value of a has we can find. Now v max is a omega. So basically from this we can solve the question. But this is not correct. A factor of 2 is missing. If you solve this, you will get answer exactly half of what we have got here. That means if you solve this, you can see you will get answer 1. So let's just do this for, this will be interesting. So uh, if you see what is the value of a omega coming out, so you divide this by omega itself. So this will become m omega a, that should be equals to q e naught upon omega. So that means omega a becomes q e naught upon m omega, right? Now put the values. Q is 1, e naught is 1, and this will become 1 again. So that means 1, and hence, as I said, this becomes 1 meter per second, which is not right. Now where are we going wrong? Let's try to analyze. See what's happened. Let's first understand what happens in SHM. This is the block. Let us say this is the mean position, MP. This is the positive extreme, okay, and this is the negative extreme, let us say, okay. Now here the velocity, let's say the block is performing SHM, okay. So the moment block reaches at this position, and let's say it's going in the negative x direction, let's say, okay, so it's about to go in this direction. So what happens here? The velocity is maximum. Now the moment block crosses this position, जैसे ये थोड़ा सा लेफ्ट में आएगा, force will start acting in the positive x direction. So direction of force is this. So block goes. Its momentum, or we can say its velocity, becomes 0 from v naught. Force is continuously acting in positive direction. Again it comes back to this position. Its velocity again becomes v naught, and force is still acting in positive direction. So basically in this whole half oscillation, force was acting in the positive direction. Its velocity becomes 0 from v naught, and again it becomes v naught. So if you see the change in momentum, it's 2 mv naught from here till here, correct? And the force continuously was acting in the positive direction in this cycle, half cycle. Now in our case, what is happening? When the particle starts from 0, the force is acting in the positive direction. The force is 0 here, and it starts acting in the positive direction. And velocity is also in the positive. Velocity is being created in the positive direction. We have to understand this. So till the time force will complete its half cycle, we realize that this is the half cycle of the force. The velocity will be created. That means velocity will continuously being added up. That means velocity हमेशा बढ़ता जाएगा. Velocity will getting acceleration की वजह से velocity will continuously increase. So if you apply the concept of SHM, you have to think the change in the momentum. Change in the momentum will be again 2 mv naught, correct? See, यहाँ से यहाँ तक फोर्स का हाफ साइकिल कंप्लीट हुआ. यहाँ पे ऑलरेडी वेलोसिटी नेगेटिव होती है. तो फोर्स का जो हाफ साइकिल, मतलब फोर्स का हाफ साइकिल क्या करता है? पहले इस नेगेटिव वेलोसिटी को जीरो करता है एंड अगेन जीरो से पॉजिटिव पे लेके आता है. बट जब यहाँ पे फोर्स का हाफ साइकिल से अपन यहाँ स्टार्ट कर रहे हैं, दैट तो यहाँ पे वेलोसिटी जीरो है ऑलरेडी. दैट मीन्स ये 2 ए ओमेगा तक पहुंच जाएगा. इफ यू थिंक फ्रॉम द पर्सपेक्टिव ऑफ चेंज इन मोमेंटम, तो वो 2 वी नॉट का चेंज आ जाएगा. तो आंसर वुड हैव बीन 2 ए ओमेगा. I hope I was able to convince you कि what went wrong in the SHM method. It's not that it's not applicable. It is certainly is applicable. It's just that we were required to be slightly careful. So 2 a omega answer होगा हमारा, and hence we can say that 2 meter per second would have been the correct answer. तो 2 a omega use करके 2 meter per second आ जाएगा, right? I hope you would have enjoyed this solution. That's it. Thank you.